Okay, so this is another example too. From the question, it says that 0.05 meter cube of a gas at 6.9 bar expands reversibly in a cylinder behind a piston according to the law PV exponent 1.2, which is equal to C, until the volume is what? Is 0.08 meter cube. Calculate the work done by the gas and sketch the process on a PV diagram. So first of all, we're going to write our data down. Then we see how the diagram also go by. So let's see. So our data. So first, our initial pressure, our final pressure, our initial volume, our final volume. So let's see. So 0.05 meter cube of a gas. So this is our initial what? Initial volume 0.05 meter cube. Then we have our P1 being 6.9 times 10 raised to the power of 5. Then we have our P2. Let's see. So in a cylinder. So that means that at this point, say that until the volume is what? Until the volume is 0.08. So that means our final pressure wasn't given. So that means we can bring our question mark here. And lastly, our final volume was given as 0.08 meter cube. So how do you go by? So with this, we can use the two formulas to do it, because from this you are given the law of PV exponent 1.2, okay, to be equal to C. Now, this formula is very applicable to the, especially when you have PV exponent n is equal to C. Whenever this n here is greater than 1, okay, so when it's greater, n is greater than 1 or is less than 1, that is when it is applicable. But when it is exactly 1, we can't use this formula to solve the question. So V2 minus V1 on what? On 1 minus n. So let's see. Let's solve it together. So first of all, I know my n, right? So I know that my n is equal to 1.2. I know my final pressure. No, I don't know. My volume was given. My final volume was given. So let's see. So let's solve for the P2. So we know that the law is saying P V, right? Exponent 1.2 is equal to C. So you have V1 exponent 1.2 is equal to P2, our V2 exponent 1.2 over here is equal to C. Now we need our what? Our final pressure. So you can say that our P2, alright, our V2 1.2 is equal to P1 V1 1.2 here. So you divide. Okay, so now let's see. So now we divide both sides by V2 1.2. The same thing, V2 1.2. We divide both sides. So now I have our P2 to be equal to. So now you can even factorize this one out again by having our V1 on what? Our V2 all exponent 1.2 times what? Times P1. Alright, so let's see. So now let's substitute the given information within. We're gonna have P2 to be equal to, so what's our V1? V1 was 0.05 on, what is our V2? our V2 was 0.08 exponent 1.2 here times our P1, which is 6.9. Alright, times 10 to the power 10 to the power 5. So what are you going to get for our P2? So we get our calculus and we say our P2 is equal to 0.05, okay, on 0.08 all exponent 1.2 multiplied by the 6.9 times 10 raised to the power 5 here. So that means we're going to get, so let's do it together. So we're going to get our P2, to be equal to 3.926 times 10 raised to the power 5 here. So now we substitute it into the what? The given equation. So we know that our W is equal to, so from this we substitute them two into it. So you're going to have W to be equal to, what's our P2? So 3.926 times, so you can choose to factorize times 10 to the power 5 out. So what's our V2? So 0.08 minus, what is our P1? So 6.9 times, then the V1 here, 0.05 here. Alright, on what are we going to get for this one too? Then we have 1 minus, our n is what? 1.2. And don't forget that the whole of this will be multiplied by the what? Times 10 raised to the power what? 5 there, because we have factorized both of them from it. So now we're going to have the W to be equal to, so let's point this, then multiply by the 10 raised to the power what? 5 there. So you're going to get 3.926 times 0.08 minus 6.9 times 0.05, then minus 1.2. Okay, then multiply times. Okay, so at the end we're going to get our W to be equal to 1,546 Newton meter, which is equivalent to 1,548. So don't forget this, please. This is being multiplied by 10 with the power 5 here. It won't go there, that is why. So that is the reason why. Okay, yeah, over here. Thank you very much. The diagram, alright, we're supposed to sketch them. So how do you go by? So now let's see. So first of all, before you go by, you draw your volume to, so this is your volume, the PV diagram. This is your P here. Alright, so first of all, we need our initial pressure here. So you can have our initial pressure at this point over here. So you can have our P1 here. Then we can have our P2 here. Then next to we have our initial volume. We have our final volume too here. Alright. So we just trace this to this side. So something like this. We also trace this side to this 2 as well. So that means from this you're going to have something like this. Then lastly from this side to as well. Then from here to here have the curve diagram here. So this becomes our PV. Here exponent n is equal to C. Alright, so this is the curve part. So from these two, you go through with the question 2 as well. So this is typically of how you're going to get it. So let's see. So first of all, you can see that you were having the initial pressure to be 0.05, then the final to be 0.08 here. Then for the pressure 2, you were given, so you can see that from this, you were given the initial pressure 2 as well, which was what? So initially it was at 1.2. Alright, so this one is in bar. Then lastly to what? To the final. So the final was 6.9. So this will move to this part, this to move from this part, and this to move to this part here. So from here to here, it will now what? Decrease. So it's like a curve from here. So that is all. Let me do it well here again. Okay. We have PV. Thank you.